Okay, so the important landmarks in these graphs have already been worked out in the table in part E. So I will just briefly explain why they are straight lines and curves and so on. Okay, there's nothing much to say about total energy. Total energy is constant. That's why it's a horizontal line. It doesn't change regardless of the position of the oscillation. Next, I want to talk about GPE. The formula for GP is mgh. So for this oscillation, basically height of 0 is when the oscillation is at the lowest position and the height increases as the oscillation goes towards the higher positions. So the formula is mgh. So GPE varies linearly with height, and that's why it's a straight line graph starting from 0 here and increasing linearly towards higher positions. Okay, next let's talk about the EPE. For elastic potential energy, it depends on the extension. It's half kx squared. So the extension is 0 as the highest position, and the extension increases as the oscillation goes into lower positions. So since it's unstretched here, the EP starts off being 0 here. Now the formula for EP is half kx squared. So the EP does not vary linearly with extension. It varies according to the square of the extension. That's why it has got to be a quadratic curve. In fact, going from here to here we double the extension. That's why the EP went from here to be 4 times of this. Alright? Next, the KE, right? So the KE actually has a formula too. It reads like this. It's actually just half m and then v squared. V squared is this thing, and you can actually get this expression from your formula list, but I expect that you actually can write it down on your own. So the KE varies according to displacement. Displacement is 0 at the equilibrium position, and displacement increases in both directions. So at the extreme positions, the KE is 0 because the oscillation is at rest, and is maximum at the middle. Now this is actually a quadratic curve. You can say you can tell that it's quadratic because we have the formula, right? It's actually there's an x squared term here. So it's actually an inverted U-shaped graph. It's a quadratic curve. Okay, so the important thing about sketching all these graphs is you got to know whether they are straight line graphs or whether they are quadratic graphs or not. Alright? Okay, that's all I have to say. Ta-ta!